upright, naked bodies, and ultimately, the brilliant brain in our heads. Deep inside the job plan that makes each and every animal on Earth, even human ones, is a common toolbox of genes, the hammers and saws of DNA, arriving and departing at just the right stages of development to get the job done. It's as if nature ran a body shop, banging out model after model from knockoff parts. Game inventor Will Wright is wondering how the toolkit played a role in the evolution of key parts of our bodies, like that cool grasping tool at the end of our arms.
So evolution has discovered these toolkit genes that it's using to construct bodies in interesting, novel, but yet very simple ways. So I'm wondering how the human body got to where it is, and the human hand, what stages did it go through to kind of get to where it is today?
In fact, the evolutionary stages that will one day lead to something so versatile as our hand really got going with a fish. For decades, paleontologist Neil Shubin had been searching for a missing link, fossils from the first of our ancestors to walk on land. Then something extraordinary happened.
It was July 2004 in the Arctic. We were digging in the rocks, and one of my colleagues calls out, "Hey guys, what's this?" When I first saw this thing, it was one of the most remarkable experiences in my scientific career.
Shubin had come face to face with a 375-million-year-old intermediary between fish and amphibian, and a piece of our own evolutionary past.
This is an unbelievably special kind of fish. Not every fish had a neck. In fact, this is the first fish that had a neck. This is the first fish that had a wrist.
Shubin and his colleagues named the creature Tiktaalik, a native Arctic word for large freshwater fish.
So if you look at Tiktaalik, what you see is, the upper arm, forearm, and the wrist. I mean, just compare it to my own body. Here's my forearm. Here's the wrist of Tiktaalik. Here's my wrist. Here are the palm bones of Tiktaalik. Here's the palm bone. Here's my own palm bones. I mean, these are pieces of my own body seen all in a fish.
Hands are an extraordinary human tool. Yet within it are component parts modified over millions of years. But why did the change happen here, in this fish, at this time? After traveling from one genetics lab to another, Will Wright can in turn offer spores unique visualization tools to a scientist. Using the game's creature creator, Neil Shubin will first try to bring his prehistoric fishapod, Tiktaalik, to life. And then we'll get a sense of the evolutionary forces in play that would one day lead to the human hand.
Let me do a cleaner slate. I'll just take a body.
Grab the arm.
I see. So I'm going,
yeah, there you go.
I'm making a Tiktaalik.
Pick a mouth from the second palate on the very top,
There.
yeah.
Okay.
Some are omnivores, some are carnivores.
Okay.
Was Tiktaalik a carnivore?
Yes, very much so. So this one really looks like a Tiktaalik mouth.
What's interesting is when you mutate these genes in the laboratory or through natural mutation, you can actually tweak the body plan of organisms, kind of like what we're doing here to some extent,
Okay, so in this case, the player is playing the role of the gene.
Right.
That's pretty good. There's Tiktaalik's head. Now let's make it a little longer. Let's make it a little flatter.
It's as if Neil Shubin has a toolkit of genes, and as he works, Tiktaalik takes shape.
What do you want next?
I would love to put some limbs on this thing, or fins.
Is there a limb that looks like a fin?
Yeah, just drag them out
Okay.
until they connect. Yeah. Those would
And
hit
at
all the bone parts.
Yeah, this
that we
is
have.
kind of really kind of close. It had the bone parts we have.
Okay.
And yet, it didn't have fingers, okay? But it had a fin webbing. So this is sort of approximating that.
It's interesting that something as versatile as the human hand could actually be coming from something as seemingly simple as a fin.
Yeah, I know. That's what looking in the distant past shows you. And you find the context for the origin of many structures is utterly different from how they're being used today.
Sounds pretty tough there, doesn't it?
Tiktaalik has arrived.
Yeah.
As with other mutations, genes bring on the change, but the environment determines if the change will survive. 375 million years ago, Tiktaalik swam in rivers filled with fierce predators. Some over 16 feet long, bearing teeth the size of railroad spikes.
If you're living in a fish-eat-fish world, there are three strategies. Get big, because big fish eat little fish. Get armor, because that protects you, or get out of the way, avoid the fight.
When Tiktaalik changed its fins, a whole new strategy emerged.
And it looks like Tiktaalik was getting out of the way, because again, if you look at the structure of the fin, this is a thing that's built to do a push-up, to support itself on the ground, either in the bottom of the water or on the mudflats. So this is a creature that was clearly getting away from the fight, if you will.
One small step for fish, one giant leap for life onto land. All that's left is to find out how this change to fin and bone occurs. But for that, the Tiktaalik fossil is missing a key ingredient. It's too old to retain any DNA. In its place, Tiktaalik's closest living relatives, sharks, skates, and paddlefish, can provide Shubin a way to investigate toolkit genes. In the lab, he can tinker with fin mutations to discover how they may have redesigned Tiktaalik. The body of an adult skate is encircled by a pair of majestic pectoral fins. And building fins is exactly what interests Neil Shubin.
Most of the body.
These are mind-blowingly gorgeous. I mean, just the structure you see so clearly.
These are actually the most primitive living animals that have appendages, that have fins.
So we're actually sharing a lot of our toolkit genes with this little guy here.
Yeah, it's remarkable. Despite the fact that, it's been over 400 million years since we shared a common ancestor with these things, the toolkit genes are largely the same.
Will Wright is getting a first-hand view of a fish hand in the making.
What you're seeing on the top there, in the upper left, is you're seeing the normal dorsal fin of a skate. Now, if you treat the developing skate with a chemical, in this case, like vitamin A, it causes a single gene to be turned on in the wrong place.
All right.
And what you get is the fin on the bottom right there, where you see it has all those bones sticking out. It looks very different.
So that bottom one looks surprisingly like the Tiktaalik fin.
What it's really showing how just changing a single toolkit gene, where it's active, perhaps even when it's active, I mean, that could change the whole anatomy of the fin.
Experiments like these are filling in the pieces to Tiktaalik's story and to our own body's origins. Fortunately for us, a fish developed the means to move on land some 375 million years ago, giving rise to our terrestrial ancestors. What followed were countless design changes. But once on land, there were clear advantages for highly active animals. They needed new body structure, and few were more important than a retooled heart. Energetic bodies, especially ones with large brains, need lots of fuel and oxygen delivered to every cell of the body. This is where a plumbing system with a souped-up pump comes in. Every second or so of every minute, night and day, without fail for your entire life, your heart beats. It has to, or you're dead. The origins of the four-chambered human heart go back more than 500 million years to a simple pulsing tube in an ancient marine filter feeder. This is the moment when toolkit genes added complexity to hearts. Hearts have evolved into so many shapes and forms. Fish have 2 chambers. Amphibians and reptiles have 3 chambers. All mammals, including humans, have 4. With each increase, blood and oxygen flows at higher concentrations. Tissues produce more energy. A higher level of activity is sustained. But how do toolkit genes fuel evolution's capacity to re-engineer a heart? To answer that, scientists turn to a vertebrate relative, a sea squirt.
So these sea squirts have a heart as well.
Yeah, they do have a heart that lies right there at the base of the adult. You can hardly see it, but you can see the gut. That's this orange area, and the heart just lies next to it.
Don't let the simplicity of that adult deceive you. That's our closest living relative. It's a close relative of the vertebrates, and it has quite a respectable heart underneath that goo.
close to the gap.
The real action is once